Hi, so me and Stephen looked over having fun with information processing. So Axon and Schifrin model. This is, like I said, it's the best known. You've probably seen this in a million psychological books, and it is how memory is said to be shown. It includes short-term memory, long-term memory, and problems with brain damaged patients. So to explain this, everybody sees input. That's using all your senses. That's classed in this as environment input. Sensory memory is then just that information being processed into some sort of filing cabinet, we can say, where the information is sorted for whatever reason. It might be like all the sites are in one area, that kind of basic analogy. Then we give it a little bit of attention, it becomes a short-term memory. These are things that we can remember for maybe just a couple of minutes. It's well known that the sort of 7 plus or minus 2 rule, where you can, if you're given a certain number of digits, the average is 7 digits remembered plus or minus 2. What happens with this is the rehearsal loop. This is mean if you hear this information, see this information, taste this information over and over again, you can then recall it into your long-term memory. That's what happens when we go from short-term to long-term. It's from that repetitive information being held inside the brain and become a long-term memory. This becomes from rehearsal and retrieval. So once we've heard it a lot of times, we then use word associations of the different senses that we can then recall that from long-term memory. And this is from rehearsal, which is practicing it, and then retrieving it and using it again at a later date. Craig and Lockhart, again, I said this contradicts the first one, and they say this is through levels. Instead of short-term, long-term memory, we have different levels, and this is what something looks like, what something sounds like, and what something means. This is shown as depth process. As you can see, it's shallow, short-term memory, and deep. Okay, this is information processing, just like the first one, but it's different levels of memory. Crick and Lockhart say that according to what you see, it's only a shallow memory. So this is almost less than short-term memory. This is the sensory memory we just mentioned. Phonetic is this what you hear. This is a short-term memory that you hear it and you can repeat it. Everybody knows that if you hear a sentence, you can easily repeat it with little to no difficulty. Or if you hear a number, you can retrieve it. Even songs, we all know, everyone can remember a large amount of lyrics. What they actually come to find is that when something has meaning, it becomes a deep memory. By deep memory, it means something that You can use association, like just on the first one. You remember it over and over again because it hits so depth. This is a depth processing. This means this deep, meaningful memories go above and beyond what short-term memory does, and that goes long-term memory. This means, like I said, where it says that on the bullet points, information analysed in the shallow part is quickly forgotten. We can maybe a few seconds, but the more deeper and deeper we get, the more long-term it becomes. This shows that the biggest contradiction is the repetition does not become part of memory. The first one, that's what it said. Once you repeat it and repeat it and repeat it and repeat it, it moves from short term to long term. Drake and Lockhart said, no, that's not the issue. What happens is if it is a deep memory, if it's something that means something to you, it has an impact, it has an issue, it moves into long term memory and is much quicker, and the information is readily available for a long period of time. They would do this by relaying up to different words and then asking the test subjects 3 questions, either a shallow, a phonetic, or semantic. And they found that more people, the semantic question was was more regularly selected because it had meaning. And the people that were tested showed that these meaningful questions through association were instantly remembered. Finally, the parallel distributed processing or connectionist model. Okay, this is where math meets psychology. As you can see right here, there is a number of different areas, different things on there, from social relations to school, from daycare, healthcare, physical development, information processing. It's a wide range of factors that are included. They're classed as integers. This shows that based after the idea that there aren't 2 areas of memory but 1. So that shows that all memories are just thrown into this big mixing pot, and it is based on connection, which is where we go next. This is memories based on nodes that link to one another, allowing the person to remember things that are connected to one of those nodes. For example, we'll take family. When you are thinking of family, you think of peers almost as family. Social relations. You can do divorce, school, daycare is linked to divorce, which is linked to family. All of those are connected in some sort of way that become that memory of family. Another example, for example, right through the middle, these are classed as the hidden ones, which are things that we remember for a longer period of time. So learning, social, school, moral development could be hidden. It depends how the person is, but there's 3 factors of input, hidden, and output. So we could input something that causes a link to something else, which becomes hidden, and then we get an output. An example of this could be we have family. If the input into that is a negative memory, that becomes hidden and would not be seen on the surface, but the output could be in later life that person may have a negative view on a family situation. In order to create long-term memories, new nodes will need to be created that are linked to other nodes in the memory. So just as I explained, the more connections, the more relationships between each memory we have, the more the memory becomes developed into a stronger long-term memory. The more connections, the easier it is to recall, as we can use these nodes and mathematical equation to go down these rabbit holes and see where the link is completed. Education and information processing. What does all this mean for teaching in the classroom? Obviously, we're all aiming to be teaching in the classroom or in a coaching environment, so we need to know why this is happening. A lot of learning is based on the idea of rote memorization. In facts, the materials, or facts and materials. When we say that, I honestly think, as an Englishman, America is much more based on that memorization, the repetitive nature, the cramming the night before a test. But we realise now that it's not memorization of a short period of time. We need to be able to do it periodically and get that into the long-term memory, in my opinion. Teachers should consider which theory best suits their classroom and utilise it. Okay, so I explained 3 of the different areas, different models, sorry. So the first one, teachers should allow students time to rehearse the information, allow it to move from short-term memory to long-term memory. So just as I said, we need periodic re-involvement from that short-term, with rehearsal and retrieval to get to the long-term memory. The next, teachers should make sure that students' attention isn't diverted away from studying, which will lead to information not reaching deeper levels of understanding. Another aspect of that is adding meaning to what you are teaching. The children need to know what they are learning and how it is going to affect them. What's the meaning behind it? How does it affect them in their everyday life? We all say that as when we're at school. For example, me and calculus, I always thought, why would I never use this? But I think from now learning about this, if I had meaning and true, honest responses of when I would use that in day-to-day life, it would really help me. And finally, teachers should try to find a way to attach new information to already existing nodes. So make sure it's like a building block system. Once that node's there, we build on that. We build again, use the meaning, you use different areas and explain it in different ways so that all the memories can be connected together. Here are the research we used. There's a couple right there, and for the diagrams I used. Thank you.